Today we're beginning Chapter 3 of Linear Algebra. Chapter 3 is a short chapter, and we're going to be completing the following topics. Lesson 1, representing relations. Lesson 2, representing functions. Lesson 3, what is and isn't a linear function. Lesson 4, arithmetic sequences, how to write an equation and solve. Lesson 5, proportional and non-proportional relationships. And today we're going to start by talking about relations. Please label the top of your notebook 3-1, representing relations. Pause the video and do this now. Alright, our two main ideas today are we're going to learn how to represent relations as a set of ordered pairs, tables, mapping, and graph. Then we're going to find the inverse of a relation. The first vocabulary word is relation. Please copy this down with the definition. A relation is a set of ordered pairs. A relation can be represented by a set of ordered pairs, table, graph, or mapping. Our second vocabulary word is mapping. A mapping is an illustration of how each element of the domain is paired with an element in the range. An example looks like this. A mapping is two ovals where we list all our x values and our y values. So this would be an ordered pair right here, 4, 3. So we match them up together. Please pause the video as needed to write down the vocabulary words and examples. The third vocabulary word is inverse. The inverse of any relation is obtained by switching the coordinates in each ordered pair. So we have a relation down here, 0, 2, and -5, 4 are our two ordered pairs. To find the inverse of the relation, you just switch the x and y value. So I'm flipping y is now x, so I have 2, 0, 4, -5. Please copy this down in your notes. Let's talk about how to represent a relation. So example 1 says, express the relation, and it gives us a list of ordered pairs. Please copy those down in your notes. And we're going to practice writing them in a table, a graph, and a mapping. Pause the video and get your example ready. So first, if we list this set of ordered pairs as a table, we're going to make a x and a y table, and you can just copy down a t-chart. Label this x and this y. You're going to list all the x coordinates in the first column and all the y coordinates in the second column. So notice we have 4, -2, -3, 2, and 0. And then we did the same with our y values. So this is how you would represent this relation in a table. Now, if we were to graph the list of ordered pairs that you had in your example, we would make a quick coordinate graph with 4 quadrants. So I would list -4, 2. Actually, that's -3. Sorry, guys. 2. Here is my -2, -1. I've got 0, -4. I've got +2, -4. And my last ordered pair is 4, +3. So if they ask you to represent the relation as a graph, you would copy this down. Please take a minute, put that in your notes. The last way we represent a relation is through mapping. So here we're going to list all the x values in set x and the y values in set y. Then you draw an arrow from the x value to the corresponding y value. So our list of ordered pairs, our first one was 4, 3. The second list of ordered pairs was -2, -1. We have -3, 2. And then the last two ordered pairs, we had 2, -4, and 0, -4. We do not write -4 twice, but we show that both ordered pairs point to -4. All right, you try. We're going to determine the domain and range for the relation. Last year, you may have learned that a domain are all the x values and the range is all the y values. So if I'm going to look for all the domain numbers and all the range numbers, I'm going to be looking at my x and y values. So in this example, the domain are all my x values. When we list them, we use the brackets, and we also list them in order from least to greatest. So -3, -2, 0, +2, and +4. Then you go through and you do the same thing for the range. Remember, we had 2 -4s in our mapping, or in our list of ordered pairs, but we only list it once in our mapping. We only list it once when we put our set of data for our range. Again, we're going to list them in order from least to greatest. So I have -4, and I just write it once. I have -1, +2, and +3. All right, let's think about this problem. Express this relation as a mapping. Well, you can eliminate A and B because they're both not maps. So let's look at C and D. Which one is showing the correct mapping of the relation above? If you said C, you were correct. 3, -2, 4, 6, 5, 2, -1, 3. Try this one. Determine the domain and range of the relation. If you said A, -1, 3, 4, 5 for the domain, -2, 2, 3, and 6 for the range, you were correct. Remember, domain is x value, range is the y value. And we put them in order from least to greatest. And we don't repeat numbers. Now we're going to look at a word problem. It says the table shows the percent of students satisfied with their grades at the time of the survey. When I look at this table, I always put x on top, y on the bottom. The domain is the year, and the range depends on the year. So our y value is on the bottom. X is always your dependent or independent variable. Y is always your dependent. So if I'm going to determine the domain and the range, I would list this. The domain is 1996, 1999, 2002, and so on. And the range is the percent that was satisfied. If I'm going to graph the data, I would make a quick graph listing out my years on my x-axis. And then my percent is on my y-axis. So here again, I'm just plotting my ordered pairs. In 1996, there's my percent, 1999. Notice how it's approximate. We went up by tens on the percent side and by threes on the year. What conclusions could we make from that data? That our satisfaction increased from 1996 to 2002, but then decreased from 2002 to 2005. So just going back, interpreting that graph, how we have an increase and then a decrease.